This video is all about using pipe flow expert software to calculate flow rate of gas pipeline with Weymouth equation. So this is a problem. They say calculate the flow rate using the Weymouth equation in a gas pipeline system 15 miles long. The nominal size is 12 inches pipe with 0.250 inch wall thickness at an efficiency of 0.95. The upstream pressure is 1200 psi A, that is psi absolute, and the delivery pressure required at the end of the pipe segment is 750 psi absolute. Use gas gravity equal to 0.59 and viscosity equal to 0.00008 pounds per feet seconds. The following temperatures of the gas is equal to 75 degrees Fahrenheit. Base pressure equal to 14.7 psi absolute. And a base temperature equal to 60% Fahrenheit, assuming compressibility factor to be 0.94. Negligible elevational difference along the pipe. How does this compare with the now let's go to the software. Let's open the software. Now this is software. This is a pipe flow expert software version 8.16. So now we are given a problem. Now the problem now for us to be able to solve this problem, what we do now is now having known that, what we do now, we just add a tank here. So the tank, okay, this is in our problem is in imperial, so this is in metering, so I will need to change it to imperial units. Now it's in imperial units. I need to change it to imperial units. And this is in gauge. Why they gave us in absolute? Although let me now change this to absolute. The result will come out as absolute, but you cannot change. Let me see. You can't change the pressure. You can't change the pressure to absolute here, so it just still remains gauge pressure. So now we're going to work with gauge pressure, but what we do is, since the parameters are given in absolute, we convert them to um, since the parameters are given in absolute, convert it to gauge pressure to now to input into the software. So that is what we're going to do. That is what we'll be doing now. So that is all for now. I will just say okay, and let me go back. Let's go back. Okay, we'll go back to unit again. The gas flow rate, we are using that is million standard cubic feet per day. That is what we're going to be using. The standard the base pressure is 60 degree Fahrenheit. Now we cannot make changes here. Ordinarily what they gave us was 14.7, but we can choose this as approximately 14.7. Now, so having choose that means the atmospheric will be at this point. So now we'll be working with this. Now, so we are good to go. Now the units, we're good to go. Let me now go back. Sorry. Let me go back to the unit. This calculation, we need to change this to compressible gas flow. Now, they said we should use Weymouth isothermal flow energy, so that flow equation, sorry. Now the efficiency, when we're supposed to change the efficiency they gave us was 0.95. Is 0.95. Now we're not, it's not going to be an ideal gas. There is a custom compressibility factor they gave us, so now we have to change this. We have to change it to the compressibility factor they gave us was 0.94. 0.94. We have so we're good to go here. So how to make that changes is you just go to the unit tab, select the specific unit, you go to the calculation tab, you now make these changes here. So that is what I did. And I also make some changes here, which is the gas flow. Um, Although the atmospheric pressure we cannot change it, we can still not change this. So, but we are using an approximate value of 14.696, but they gave us 14.7. So I will just say okay. Now I will now need to draw a line. I will now click on the add pipe button to draw pipeline. Now I will now draw a line from here to any arbitrary point. Now they said we should change the default pipe value. So I would say yes to change it, to make the changes. Now they gave us, so we needed to make some amendments now. So we are given, so what I will do now for me to um out, because we are going to also calculate using general equation. So now what I will do is I will put the proper pipe roughness they gave us for that one, but the pipe roughness does not affect this equation because already we have calculated the pipe efficiency. We have imputed the high pipe efficiency, which is 0.95. So now we are going to make changes. We're going to create a new pipe. Let's say we're adding a pipe. Let me just call the pipe. Let me call it another name. Let me just say it's a steel pipe. Let's say steel pipe gas. Now the roughness is 0.0007 inch. Now we'll just add it. We'll select this. Now we needed to add new size. So the new size we're adding, actually they gave us of nominal size 12 inches. So now we're going to select this 12-inch size here, and the internal diameter, the wall thickness. Well, let me go back. Let's go back. Just cancel this. Go back. Let's look at the size of 12-inch, the outer diameter of 12-inch. So now, then I will write it down. Let's look at the outer diameters of 12-inch. Because the outer diameters of 12 inch is constant. Let me just choose any arbitrary size here. So the 12-inch size, the outer diameter of 12-inch is 12.750 inches. So that is what we're going to use to make that calculation. So now let's go back. Let's select this gas again we created. Then now let's add new size. and the size is 12-inch, which is already there. The outer diameter, then the wall thickness is 0.250. 0.250. The outer diameter is 12.750. Now, if you subtract two, if it's the outer diameter minus 2 times the wall thickness will give you 12.250. Now, let's say the weight, we just choose an arbitrary value because the weight of the pipe does not have any effect on this, on the on flow, that is on fluid flow analysis. So it doesn't have any effect. So I will just click add new entry. Now, I will now click this button to select it, to transfer selected size. So now I will just say save. Now, the length of the pipe is 15 miles. Let's now convert 15 miles using this conversion table. Although I know one mile is equal to 5,220. So now, but let's do it here instead of just now. And I need to change this to mile, this to feet. Now, if you can see, 1 mile is 5,280. So now we are looking at 15 miles, which is 79,200. So that is what we're going to impute into the length. So now the length will now be 79,200. Now, having done all this, we're good to go. We have changed this initially, so we're good to go. So I'll just click this OK button here. Now we're good now. Now let's go back. For this point, they say from the beginning, from the upstream pressure is 1,200 psi absolute. Now, but we're going to impute psi gauge. So to do psi gauge, let's go back to calculator. We go to scientific. So now we have 1,200 minus 14.696, because that was what 14.696, that is the atmospheric pressure, the base pressure of this software. Although the base pressure they gave us is 14.7, but 14.696 is the base pressure of this software. So that is what we're going to use. We enter. So this is the value we got. So now we are going to impute this value. We are going to also do the same in that other one, but in the end, the delivery pressure. But we are not going to use the calculator. We just do it just the way we did this, so that we won't waste more of our time. So now this is 11.85. Who are you talking to, Daddy? So this is 1,185.304. We enter. Then at this other point, we'll now use an end pressure. The end pressure should be, now converting it to gauge pressure, we'll have, that is 750 minus, let me just do it instead of assuming you know it. So now let me now say 750 minus 14.696, which is 735.304. So that is what we're going to use here now. We are going to say 735.34. So 304. So now, so that is the gauge pressure here now. So we are good to go. So that's it. We are good to go. So now we have input we have input the upstream pressure and the delivery pressure. So we I believe we are through with all we're supposed to put in here now. We have also is a fluid. So now to change the fluid here is water. So to change the fluid, you can either come here, change the fluid, or you go to this fluid tab, click change fluid here. Now you will now make changes now. The fluid is at temperature 75 degree. The temperature of the fluid is 75 degree Fahrenheit. So now there is no such pressure here. And let me see. And you have a gas gravity of 0.59. So the one that is closer, we're still on liquid. Let's go to gas. The value that is closer is is um is natural gas. Natural gas, you have 0.6 here. So we are going to make use of this gas here. Now, but the temperature of the gas here is 60 degree. We're not using 60 degree, we're using 75. Now, the specific gravity here is 0.6. So, but we want to make use of 0.59. So, for us to do that, we come here, we change it. We'll click this button here, which is XG, which is specific gravity. We change it to 0.59. Change the temperature here to 75, because that is the temperature of the gas. Now we say calculate to get the at atmospheric. We use it at atmospheric, but now at various temperatures and pressures, the density will vary. So now we just have to create for 0 psi first. So now psi gauge. So now I just click calculate. So this is what we have. So now we'll now save this information into that data. So it's saved now. So if you can see now, the density has changed. You see, look at it. Okay, let me just calculate again. Look at the density. It has changed. It's in line with this now. So I'll just save. So it's here now. I'll just save it to this. So we have made changes. Now we're using natural gas of specific gravity 0.59. Although that the specific gravity here is still they still roll 0.560, but the one we're using now is 0.59, because the density we calculated here now is of 0.59. So now we are done with what we are all to input into the system. So now we're going to just click calculate. So let me click calculate. They say okay, configure the now click OK. Now let's view the result. So this is the flow rate we got. We got 163.1776. So the answer we got is 160. The flow rate here now, look at it here. This is the flow rate. If you come to here now, you can also see it here. Look at the flow rate. So you look at the gas flow, which is 163.1776. Now, if you look at in this book, it was calculated to they gave this was what they calculate what they got. They got 163.26, but what we got is 163.17, let's say 178. Sorry, 163.18. Why they got by hand calculation, they get 163.26. So that is it. So now we are done with this. So now let's go back. Now they also want us to calculate using, if you look at the problem now, they want us to also calculate using the general flow equation with the Colebrook's friction factors. Now, for us to do that, the only thing we needed to do is everything is inputted. That was why I input that roughness, the material roughness. So now, the internal roughness. So now, because this is why you're going to make use of it. Now, what I will do is I will just come to this pipe button, go to calculate, change this to general. Look at the general fundamental isothermal flow equation. Now, since the customized z factor is still the same, now let's now do click OK. So we have changed the equation. We just calculate. Now let's look at what we got. What we got was 192.97 as the flow rate, 192.97. Now let's look at what they got here from their calculation. So they got 192.98. So we got from this software, we got 192.97. So it's very close, very close, decimal error. So now that is it. So now, thank you for watching. Have a nice day. Please, if you like this video, please subscribe to my channel and hit the notification bell so that I and also do well to share the video to other people that would like to learn from this, and also ask them to subscribe. Thank you.